All right, good morning, Algebra 1. Wanted to give you guys a little bit of a sense of normalcy, so I'm making sure to be holding my coffee mug here. It's still in the morning for me, so depending on when you're watching this video, good afternoon or good evening to you. But I know that normally, guys, in my lectures, I'm holding the coffee, and that's what's keeping me going in the morning. So same old, Mr. A needs his caffeine for sure. All right. Hey, hope you guys are doing good. Before I start in on this lecture, just again want to let you guys know how much I miss you. Talking to this camera still has not felt normal at all. And so I miss you guys' faces, I miss your reactions, I miss the banter that we have back and forth, and I just want to let you guys know how much I miss you, caring for you, hope you're doing well. And I'm praying for you guys every day. I know that one of the things I've told you about, I put my kid to bed every night, and one of the prayers that we do every night is for you guys. And so I want to let you know that I'm still doing that. All right, so, okay, today we are looking at Section 6 here, Chapter 10, Section 6, and we are solving quadratics by completing the square. And basically up to this point, you guys have been given multiple methods on how to solve quadratics. Quadratics basically being we have a squared in it situation. So x squared, that's going to make it a quadratic. You guys have learned how to factor. You guys have graphed quadratics. And this is going to be another method called completing the square. This method is also something that you guys are going to have to remember once you get into Algebra 2, and you might even be using a little bit of it next year for geometry. So hopefully this lesson makes a little bit of sense to you. I'm going to step off to the side, make sure that you guys pause these videos, copy down all these notes if that's helpful for you. All right, so let's get into it here. So this is all about getting a perfect square trinomial, okay? So you guys remember perfect square trinomials. That's going to be when all three terms have something special about them. The first term is a perfect square. The third term is a perfect square. And then you're going to be looking at this last sign right here, and that's going to be a plus sign. So you guys should have back on your notes from last chapter. Remember, I put them kind of over here, left them on the side, telling you about a perfect square trinomial. We also learned about perfect square binomials too. So it's all about getting a perfect square trinomial. And basically you could be given just something like this, like an x squared plus some number x. Okay? And if this is what you're given, then you're going to create a c value. So that's the third term. You're going to create a c value that makes it a perfect square trinomial. Okay? So this right here is what you're going to be using. This equation right here is what you're going to be using to create that brand new c value. Okay? And you're going to get that b from the middle term. Okay, that's going to be the coefficient of x. You're going to divide it by 2. Make sure you do that, and then you're going to square it. And you guys should know that anytime you're squaring a value, it's always going to give you a positive number. So that means that no matter what, your c value, when you get down here, is always plus, and then it's the brand new c value. Okay? All right. Now, in example 4, which we'll be doing over here, this is going to be a good one because sometimes the problem will give you a c value, and that c value may not work the way that it's given. And what I mean by may not work is that it doesn't actually create a perfect square trinomial. So you're going to have to create a new c value that will make that trinomial a perfect square. And you'll see how that works in example 4. Okay? Now, this right here is just a little bit of the kind of the generic algebraic way of saying that you have a perfect square trinomial. You have x squared, or you have some perfect square, that's your first term. Whatever the b value is, if you were to take that b, divide it by 2, and square it, that's going to create the c value. That would be the perfect square. This is really important over here. when you factor that perfect square trinomial, this is really what all your factored options are going to look like. But I do want to point out that this plus sign right here, this will be plus if the first sign right here is a plus. Now, if this first sign right here is a minus, then in here it will be a minus. So make sure you notice that. We're going to do these example problems and you're going to see what that looks like when it's a plus sign, when it's a minus sign, and what it creates when it's in the factored form. Okay? So let's take a look at some of these example problems here. Our first example, number 1, x squared minus 12x plus c. In the directions in your textbook, I just want to read those because it's a little bit different than what I have on the board. So what they're going to say, or what I said, is just find c and factor it. What the textbook is going to say, they're going to say find the value of c that makes the expression a perfect square. That's find c, okay? Then they're going to say write the expression as a square of a binomial. When they say as a square of a binomial, that's just kind of the fancy way of saying factor it, okay? So one thing, I'm trying to stay in frame here, so sorry about that if I'm kind of out of frame, in frame. As long as you can hear my voice, see the board, I think that's a little bit more important. So first problem, here we go. We're trying to find the c value, and we have x squared minus 12x plus c. Let's find that c value by using this equation right here. So what is b? b is 12. We're going to divide it by 2. Put it in parentheses there. We're going to square that value, okay? So 12 divided by 2, what we're looking at here is this is going to be 6 squared. And what that really works out to be then is 36, okay? So our brand new c value is 36. So let's write that in here. We're now going to have x squared minus 12x plus 36. So what they were looking for is that brand new c value, okay? And once we got that c value, then they ask us to factor it. Their fancy way of saying factor it, again, is write the expression as a square of a binomial. So if we look over here, this is the way it should look once it's factored. But look at the first sign. It's a minus. If this is a minus, when we factor it, it's going to be a minus sign there. Okay, we take the x squared, just write x here. Same thing, look at this example. X squared was here, we wrote x here. And then they say take b divided by 2. b is 12, and 12 divided by 2 is 6. And then make sure that you put that squared on the outside. So what we have here is our c value is 36, and our factored form is right there. That right there would be the, in parentheses, x minus 6 quantity squared. Okay, let's take a look at example 2. Same concept, finding c and then factoring it. All right, but you're going to probably notice here that 3 divided by 2 is not going to be a nice number. If you were to think, oh, I'm going to turn it into a decimal, don't. All right, those of you that love decimals, this is not the decimal type of chapter. So fractions are your friend. Keep them in the form of a fraction. All right, so we're going to take b, which is 3. We're going to go 3 divided by 2. Remember, just using this equation, b divided by 2. Put it in parentheses and square it. Like I said, 3 over 2 creates a decimal. Don't make it a decimal. And leave it like it is, but square each term. So what I mean by that is think 3 squared over 2 squared. So we're looking at 9 over 4. So that's our brand new c value, 9 over 4. Okay, so if we were to write that as a perfect square trinomial, it's going to be x squared plus 3x plus 9 over 4. Okay, so that's the c value. Now, they want the factor. And remember, this is what it looks like when it's in the factored form. So we're going to put parentheses. There's an x squared, so I put x. What's the first term? Or sorry, what's the first sign? It's a plus sign. So we put a plus sign in here. And then they're going to say, what does b over 2 look like? Well, that's right here. b was 3 divided by 2. Just leave it as 3 over 2. And then put your squared right there. So this right here is the factored form. And remember, this right here was my c value, 9 over 4. All right, let's take a look at another example. This is set up slightly different. They're just going to say solve. They don't give you that plus c that you have to fill in. So you have basically two options here. First option, leave the 3 there and try to solve for a brand new c value. Or you could take the 3 and move it in and put it with the other side, creating a trinomial. Now let's see what it looks like if we do that. X squared minus 2x minus 3. Now, solving this would mean that it could be factored. So you got to double check, could this factor? So the factors of 3 are 3 and 1. That's it. It's a prime number. Can 3 and 1 make 2? And they can. So we do know that this will factor. We don't even have to use completing the square. There's going to be very few of these problems in your homework, but just double check whenever they say solve. If you could factor it with what they present you with, try doing that. So let's go in our double parentheses. When these signs here are minus and minus, in the parentheses, they're opposites, plus and minus. X squared breaks down into x and x. And then again, 3 is 3 and 1. What would the order need to be to create a negative 2 in the middle? We'd have to put the negative 3 there, the positive 1 there. Because again, negative 3 plus 1 makes that negative 2. That's what we're looking for. And we're not done yet. We got to solve it. So, x plus 1, solving that is going to give us negative 1. X minus 3, solving that is 3. Those are the two values that we have there. So we solved it. Everything worked out. Negative 1, positive 3. All right, let's take a look at the last one here, example 4. I've already given you a hint. Remember, example 4, sometimes they give you a c value that won't work. So let's walk through our steps here. And these steps here mean, can we take something out? It's presented to us as a trinomial, so maybe we could factor it. Maybe it could be factored. We'll see. Just like example 3 did factor. I don't know if 4 will, so let's walk through it. I do see that all of these numbers share a 3 in common. So factor that 3 out. That's always a common thing amongst all these problems with quadratics. Factor out a number if you can, simplifying it. So let's take that 3 out, and then what do we have left over? We're going to have x squared minus 8x plus 9. So basically I just divided all of these numbers here by 3. Okay? Now, if I take a look at that trinomial, for starters, it's not a perfect square. Okay? Even though x squared is a perfect square, 9 is a perfect square, it makes 3 and 3, but 3 and 3 don't make 8. That's what's telling me that it's not actually a perfect square yet the way that it is. So if we're looking at this and thinking, oh, it is a perfect square, go through your steps, factor it. You're not going to create 8 in that middle term. So it's not a perfect square. And looking at 9, any other factors, 1 and 9, Could those create 8? They might be able to create 8, right? 1 and 9. However, this sign right here, it's not going to actually create 8. Okay, I'll do a quick show just so you see what I mean. If we factor this and say that it's x and x, that's a plus, that's a minus. So these guys both have to be minus signs. If we put a 1 and a 9 there, a -1 and a -9 make -10, not -8. So I just want to show you and prove to you that it does not factor quite the way you think it would. So here's the steps that we have to go through in completing the square. So what we're going to do is we're going to take that trinomial, x squared minus 8x, and that 9 doesn't work. So we're going to take that 9 and move it to the other side, making it a -9. And I'm going to leave a blank here because I'm going to, as I said in this note, create a new c value that will make it work as a perfect square trinomial. So go through your steps. b divided by 2. Here's b. 8 divided by 2 is 4, and squared, so that's going to be 16. So I'm putting a plus 16 right there. So this, we know, is a perfect square trinomial. Now, if I put a c value here, I have to put a c value on the other side, because remember, everything in math, it's got to be equal on both sides. So up to this point, none of these other problems here required me to do that. This one said solve, but it worked out that I could factor it. These first two problems over here, all they wanted was a brand new c value that made it work, and then factor that trinomial. This one says solve, and so there's this extra step involved, where whatever you put over on the other side, the constant by itself, you have to include the brand new c value that you create. Okay? So we added 16, and this right here will make, let's see, it's going to make x minus 4 squared, and that's going to equal, let's see, we have 7 on that side. Okay, so all I'm doing, I factored the trinomial, and then -9 plus 16 gave us the 7. You got to remember from what you did yesterday, now we're solving, and we have a square. So how do we get rid of that square? We take the square root of both sides. These guys will cross out. X minus 4 is left, and equals, and don't forget that plus or minus. Square root of 7, you leave it. 7's prime, leave it under the radical. Don't forget that plus or minus. Again, I taught you guys about that yesterday in section 5. We got one more step, add 4. So I'm going to put that 4 right there. Those cross out, and this is my final answer. 4 plus or minus radical 7 right here. All right, guys, so I apologize. I know that was a little bit of a longer video, but this is a detailed section. I'll step off to the side, so hopefully you guys are able to copy all these notes down. If we were in class learning this, this would have been one of those days where I would have made sure you guys had to be ultra focused, pay close attention to every step. It starts out pretty straightforward with the first two examples. Really, example 3 is not too bad if you can see that it factors. So example 4, you might need to watch me go through that a couple times. All right, so again, miss you guys, love you guys, hope you're doing good.